Hello, Dr. Khan. Today we are going to talk about a review paper named State of the Art, Limit Equilibrium and Finite Element Analysis of Slope by James Michael Duncan, Fellow ASC. Uh, I am Rahul Bishash and Anika&Rahul. Together we'll talk about this review paper. So at first, let me talk about a little background of Mr. Duncan. Mr. Duncan completed his BS and MS in Civil Engineering from Georgia Tech University in 1959 and 62 respectively. Later on, he completed his PhD on 1965 from California, Berkeley. So at first, let's talk about the abstract of this paper. Uh, About 25 years ago, due to lack of proper micro supercomputer access, it was difficult to analyze the deformation of slopes and embankment accurately. But nowadays, we can uh, compute the deformation of slopes and embankment very accurately. This paper discuss about the proper requirement for accurate and useful events and suitable representation of stress-strain behavior, then advantage and limitations of finite element method for using this in practical engineering problems. In this slide, we can see a total overview of different slope stability methods. We will not discuss about those as we already discussed about those in the last classes. In this slide, mainly all the slope stability analysis and how they calculate the slope factor of safety for a certain slope. It is discussed in this slide. So we are going to skip that. So now it's crucial why the accurate analysis for engineering projects is very important. Now it is very crucial for practical engineering problems to get accurate analysis to find accurate factor of safety. Locating the critical slip surface that has the lowest factor of safety is an important part of analyzing slope stability. All of these methods appear to work fairly efficient and effectively for problems that do not involve extremely complicated slope geometries or numerical problems. So all the methods of slope analysis of equilibrium, limit equilibrium are based on some assumptions. First of all the methods employ the same definition of factor of safety. The factor of safety is the shear strength of soil divided by the shear stress required for equilibrium. In equilibrium analysis of slope stability, the stress strain behavior is ductile and the soil doesn't have a brittle curve. But here is the this is the thing that Mr. Duncan actually emphasized on this review paper, that is all the methods of slope stability analysis, they uh, mainly focus on the changes of stress of soil, not the changes of strain with the increase of the stresses. So uh, we do not know what type of changes happens in soil when the stress is increased, what type of changes in strain is happening in a soil when the stresses in a soil is increasing. So all these methods do not actually shows the linear relationship of stress and strain. All this method of slope stability analysis are based on equilibrium condition, where some of the methods actually considered force equilibrium, some of the method considered the moment equilibrium, where the slices of slip circle are either force or moment equilibrium condition. Here are some limitations of the traditional methods for analyzing slope stability, for analyzing the factor of safety of a slope. Uh, it developed actually simple conditions and approximation are necessary to apply them in real condition. Uh, Slope stability charts can yield accurate result when applied uh, in kind of preliminary analysis. For effective analysis of flat slopes with high pore pressure, the ordinary method of slices is highly inaccurate. And also, when the numerical problems are encountered in a practical problem, Bishop's modified method is also inaccurate. And in this paper, it is stated that the factor of safety estimated using multiple approaches often differs by up to 12% from one another and up to 6% from the most accurate value, assuming all equilibrium conditions are met. So here are some sources that is commonly made when we compute any analysis. So to compute any slope stability analysis or to compute any factor of safety analysis, we need to keep in mind some of the points that are the major sources of mistakes. First of all, inadequate comprehension of soil mechanics by the analyzer, inaccuracy in defining the water pressures, unit weight, and shear strengths, inability to accurately specify those quantities in the input due to lack of understanding of the computer program, inadequate verification and evaluation of analysis results by both the analyst and the reviewer. Computer results should not be relied upon without checking carefully, and analysis must be done with experience as well as extra analysis should be performed. So, in this review paper, as it's stated that all the methods of slope stability analysis, they actually do not give the accurate results, and they do not create the real scenarios. Uh, so finite element method is a solution in that case, though finite element method have some limitations as well. So Clark and Woodward introduced the finite element approach to the Geotechnical Engineering Committee in a paper they wrote for the inaugural Berkeley Conference on the Stability and Performance of Slope and Embankment. So what does finite element method do? Finite element method actually use the non-linear stress-strain relationship. That is the most important thing, non-linear stress-strain relationship. Uh, from the traditional methods, we cannot get the idea of changes of strain of a soil particle when it is under loading. So the stress-strain relationship, non-linear stress-strain relationship criteria or the scenarios is not developed in the traditional methods. So finite element method use the nonlinear stress-stress relationship for the analysis of slope stability, embankment, and dam. So consideration of nonlinear stress-stress behavior gave the finite element method great potential to use in geotechnical engineering problem, as well as to create a real-life engineering scenarios uh, more accurately than the other methods of slope stability analysis. The rest of the presentation will present by Anika Mahazavin. Thank
Hello everyone. At first, I would like to talk about the advantages of finite element method. So, in the advantages of finite element method, we can say that it is more accurate to compute stress movements and pore water pressure of embankments. And also, it can be used to analyze conditions during and following constructions. There is another advantages of it, that is, it can be used for evaluating slope stability, cracking, hydraulic fracturing, and local failures. And there is another advantage, that is, it can accurately describe the complex situations such as the nonlinear stress strain behavior, non-homogeneous conditions, and changes in geometry during construction, like embankment or excavation. Now, I will talk about the weakness of finite element method. At first, we can say that the analysis development, computer processing, and outcome review need a significant amount of time and money. So it is tough for everyone. And another thing that significant engineering time is required for efficient utilization. And in third, I can say that the availability of powerful microcomputers has reduced total cost, although they remain resource intensive. And last but not the least, mainframe computers are required for particularly large scale or three-dimensional analysis using iterative methodologies. So these things are complicated in case of finite element method, and you can say these are the disadvantages or weakness of these methods. Now I will talk about an example analysis of a finite element method on a real life case. So here in this picture you can see a dam, that is New Melons Dam. If you zoom in you can see that this portion is the dam, and on the upper side here the water level is far more different than the other side because of this implementation of this dam. So this dam was analyzed using finite element method. So here you can see the plan view of this dam and the longitudinal section, and also a figure that was implemented in the FEM model. Now I will talk about the sources of uncertainty in finite element analysis in case of this dam. At first comes the degree of compaction. Contractor achieved 100% standard Proctor compaction exceeding specified minimums, impacting material stiffness. There comes compaction water content. Specifications allowed a range in water content affecting material strength. Conservative assumptions were made, but actual water content was lower. Then there comes no test data. Zones lacking test data required estimating material properties adjusted for different in gradation and compaction. Then comes construction sequence, altered sequence with some of the main dam constructed alongside with the coffer dam had minor effects of deformations. Then comes simplified approximation of stress strain behavior. Stress strain relationships were simplified, nonlinear, and stress dependent, but didn't account for volume changes due to shear stress. And then comes reliability of field measurements. Field measurements reliability assumed, but errors occurred like erroneous pore pressure readings due to procedural mistakes. These factors highlight the complexities and uncertainties in the finite element analysis, emphasizing the need for careful consideration and validation of assumptions and input parameters. Then comes the summary of key points. At first, we can say that finite element analysis enable assessments of stress and deformations in slopes and embankments. Previously, in the general equilibrium method, the stress strain behavior were ignored, but in FEM, we can include that. And then comes considers nonlinear stress strain behavior, construction induced geometry changes, and pore pressure dissipation. However, it demands significant effort and cost. Then comes numerous dams, embankments, and slopes have been analyzed in practice using four different types of stress strain relationships. And when compared to field observation, computed deformations are frequently greater due to factors such as aging effects, simple disruptions, and discrepancies between lab and field settings. Despite errors in predicting soil qualities, finite element analyses are an important tool for engineering practice, helping to understand and address a wide range of geotechnical challenges. So here was the summary of the key points. Thank you.